Okay, so today we're looking at some trig graphs. So we want to know what the graph of sin x and cos x look like. Now they become very important later on in the course. So knowing the basic ones will help you greatly. Now we can work this out the same way we would any other unfamiliar graph. We can make up a table of values, pick some numbers for x, substitute it in, work out our y's, plot our points, and then join them up. But the problem when we do that is that students often don't see the connection between the graph of sin x and cos x and the unit circle. Now, that unit circle is extremely important, and seeing how the two relate is going to help you a lot. So what we're going to do is switch over to a couple of videos off YouTube that will show you how the graphs are related. So what we have here is the unit circle, and we're going to be graphing sine. So remembering that sine talks about the height of the triangle that's within that unit circle. For now, ignore the numbers that are along the x-axis because that's to do with radians, which is a concept that we learn later. But the shape of the graph doesn't change whether we measure it as x, 0, 1, 2, or whether we measure it in radians. The graph always looks the same. So we're starting here at 0, and what we're going to do is we're going to move this point around the unit circle, and we're going to work out what is sine of x at each of those points, and we're going to plot that on this graph. So you'll see what happens as we move around the unit circle. So it starts at 0 because sine of 0 is 0. You can check that one on your calculator, but if you think about it, it makes sense. Sine is the height of the triangle. If there's no angle, there is no height. So sine of 0 is equal to 0. But then, as we start to move around the circle, the height of the triangle increases. Now it reaches its maximum when the angle is equal to 90. Sine of 90, well, what's the maximum height we can reach here? It's a unit circle, the radius of the circle is 1. So the highest point for the graph of sine x is at 1. Then it starts to drop back down. Now it's going to hit 0 again when the angle is equal to 180, because again, the triangle has no height. So our graph starts at 0, it curves up to a maximum height of 1, and then it curves back down to 0 again. Now that's the first and second quadrant of our all stations to central unit circle. And in the first and second quadrant, sine is positive. But when we head into the third quadrant, sine becomes negative, and so the graph becomes negative. And again, the height of your triangle is going from 0, and then it's going to decrease. But in this case, we're going to go down to -1. So as we keep going around, it goes down to -1, and then in the fourth quadrant, it heads back up until we get back to where we started from at 0. So that's how we get the sine curve. The sine starts at 0, goes up to 1, back down to 0, down to -1, and then back to 0 again. So this is the basic sine curve. We've got it graphed here, so it's just what we did in that before. You can see you've got the angles for x along the x-axis. So at 0, sine of 0 is equal to 0. At 90, sine of 90 is equal to 1. That's our maximum. Then we curve back down. Sine of 180 is equal to 0. Sine of 270 is -1. And sine of 360 is 0. The sine curve then just continues repeating because what happens is that point just keeps going around and around the unit circle. So it's just replicated over and over again, and it's also replicated over the other side of the y-axis. So the sine curve is an odd function, which makes sense. If you think about it, what we've done is we've taken that graph and we've rotated it. Because if I put in sine of 30 and sine of -30, I get the opposite answer. So there's your sine curve. So the next one we're going to look at is the cosine curve. So remember that cosine is measuring the x value for the circle. So cosine, this length here, starts at 1. So it's going to start up here. So then as we start to go around the circle, the cosine, this length here, is getting smaller. So our graph starts at 1 and then it curves down. Now, as we get closer to 90, it gets smaller until eventually it reaches 0. Now, once we get past 90, remembering our unit circle, this is stations. Only sine is positive here. Cosine is now negative. So the graph has dropped below the x-axis. The distance is starting off small and it's going to get bigger as we go around. So it's heading down towards the minimum of -1. Then in the third quadrant, we're still negative, but we're heading back to 0. And then once we pass 270, cosine becomes positive and we end up back above the axis. The cosine graph continues up to 1. So it's similar to the sine curve. It has a maximum of 1, a minimum of -1. It's repeated over and over, but instead of starting at 0, it now starts at 1. So your cosine curve looks like this. It starts at 1, cos of 90 is equal to 0, cos of 180 is equal to -1, cos of 270 is equal to 0, and cos of 360 is equal to 1. So you can see it's very similar to the sine curve, but it's shifted. The cosine curve is an even function because cos of 30 is the same as cos of -30, which makes sense if you think about your unit circle. Cos is positive in the first and fourth quadrant, and it's negative in the second and third quadrant. They're reflecting at each other. So if we want to put the two graphs together and compare them, this is what it's going to look like. So you can see the sine graph is the blue one, starting at 0, heads up to 1, and then back down. Once we hit 360, we just repeat. The cosine graph is the orange one, and it starts at 1. Now, as long as you know the basic shape of the two, it's pretty easy to work out. If you ever forget which one it is, just type sine 0 or cos 0 into your calculator. Figure out whether it starts at 0 or 1 and work from there. Max is 1, minimum is -1, passes through 0 at, for the sine curve, 180 and 360, and for the cosine curve, 90 and 270, which all relates to the unit circle.